Welcome to This Explainer. Today, we're diving deep into the staggering scale of global financial fraud. We'll be looking at some of the most incredible, jaw-dropping real-world cases that have literally shaped modern history and the brilliant technology investigators are using right now to catch the perpetrators. From stolen sovereign wealth funds to massive data leaks, the world of illicit finance is vast, complex, and, honestly, absolutely fascinating when you start connecting the dots. So let's dive right into this mystery. How on earth do the world's most audacious criminals make billions of stolen dollars simply vanish? Well, when we talk about modern financial crime, we aren't talking about a bank robber running out with a duffel bag of cash. We're talking about highly sophisticated, globally coordinated networks that are custom built to take massive amounts of illicit money and launder it right through our legitimate financial systems. To really wrap our heads around how this modern fraud actually works, we first have to grasp the sheer scale of the illicit money moving around the globe today. And trust me, the numbers are hard to even fathom. 200 billion euros. Just let that number sink in for a second. This colossal figure represents the suspicious transactions that flowed through just a single Danske Bank branch in Estonia between 2007 and 2015. It's been described as possibly the largest money laundering scandal in European history and quite possibly the world. Literally, one tiny branch in Estonia became the main conduit for a massive river of illicit funds. And if you're wondering where that mountain of cash came from, it was part of a massive, coordinated web of cross-border financial movements, hiding right behind completely legitimate banking infrastructure. 23% of the incoming funds came straight from Russia, another 23% from Estonia, flowing in and then rapidly dispersing outward to places like Switzerland, Turkey, and China. It was essentially a global washing machine for money. Now, let's look at another real-world case, the infamous 1MDB scandal. The contrast here is just staggering. $4.5 billion stolen in a massive embezzlement of a Malaysian sovereign wealth fund was converted from cold, boring digital data into glamorous real-world excess. They took money meant for a nation's strategic development and used it to buy Hollywood real estate, Picasso artwork, diamond jewelry for celebrities like Miranda Kerr, and ironically enough, they even used it to fund the movie The Wolf of Wall Street. The U.S. Department of Justice literally called it the largest kleptocracy case to date. Okay, so how exactly do you pull off a heist of this magnitude and buy diamond necklaces without triggering immediate alarms at the local bank? It all comes down to exploiting a neat little legal concept called beneficial ownership. Basically, fraudsters set up endless, convoluted layers of shell companies across a bunch of different global jurisdictions. The whole goal is to make sure the true, natural person who actually owns the illicit wealth remains entirely invisible to investigators. By the time a bank actually sees a transaction, it just looks like it's coming from a completely legitimate, boring corporate entity. And the damage this tactic causes is phenomenal. For example, by manipulating beneficial ownership, a former Kazakh minister in the Ablyazov affair was able to fraudulently move a staggering $6 billion right out of Kazakhstan's BTA bank. It's cited as one of the largest cases of financial fraud in history, all made possible by simply obscuring who really controlled the money. Jumping back to the 1MDB scandal for a second, you can really see how multinational banks like Goldman Sachs, powerful politicians, and rogue financiers like Joe Low all intersect. It isn't just one bad actor sitting in a basement. It's a highly complex network of enablers all working together. Fraud on the scale? It's absolutely a team sport. Which brings us to 2016. The year the curtain finally got pulled back on this incredibly secretive offshore finance industry. Practically overnight, journalists got hit with a literal ocean of data. 11.5 million documents leaked from a single Panamanian law firm, Mossack Fonseca. This leak detailed the highly secretive offshore accounts of heads of state, mobsters, tax evaders, and billionaires. It was basically the master playbook of exactly how the world's elite hid their wealth. Edward Snowden hit the nail on the head when he tweeted about this, calling it unprecedented. And he was right. The sheer scale required journalists from over 100 media organizations in 80 countries to collaborate for more than a year. They actually had to use optical character recognition software just to make the documents readable, and then painfully cross-reference millions of names to extract the hidden truths. But here's the thing. Faced with 11.5 million files and all those complex connections, investigators quickly realized that traditional data tools were completely useless for connecting the dots. A major paradigm shift had to happen. Instead of organizing data in rigid rows and columns like a traditional relational database, investigators turned to something called graph databases. A graph database stores data natively as connected networks. Actually, it's exactly like a detective's string board come to life inside a computer. It can traverse incredibly complex multi-hop paths in milliseconds without relying on slow, cumbersome database queries. And here is how that changes the game. You start with just one suspicious account, right? Then you instantly traverse the graph to see if they share a phone number or maybe an IP address with other seemingly unrelated accounts. You can identify hidden intermediaries across multiple degrees of separation. And boom, suddenly a group of isolated transactions is instantly unmasked as a coordinated fraud ring. It was this exact combination of Neo4j's graph database technology and Linkurious' visualization software that cracked the Panama Papers. It totally empowered reporters to visually follow the flow of illicit money globally, finding those hidden, winding paths between corrupt politicians and their offshore shell companies. But look, the power of graph technology didn't just stop with investigative journalism. It is now the ultimate magnifying glass for modern financial institutions to stop fraud before it even happens. Look at the real-world impact happening right now. Massive companies are seeing incredible results by modeling their data as a connected transaction graph. BNP Paribas reduced fraud by 20%. IUVD saw a 200% increase in fraud detection, saving over $40 million a year. And Zurich Insurance? They use graphs to instantly triage staged auto accidents, those schemes known as crash for cash, by instantly spotting if supposedly random drivers actually share a home address or a bank account. And because time is so absolutely critical in stopping these crimes, graph databases can track temporal dynamics, meaning they monitor how relationships build progressively. Say user A logs in on day 1, and then on month 6, user B uses the exact same device. A static snapshot of data might totally miss that, but a graph spots that expanding fraud ring over months, flagging the whole network without getting bogged down by the sheer volume of data. And this matters a lot, because financial crime isn't just a victimless whiteboard exercise. Transaction laundering alone accounted for over $200 billion in the US in just 1 year. That is illicit money funding illegal operations, undermining the global economy, and slowly eroding trust in democratic institutions. It's an epidemic that costs all of us billions of dollars every single year. So, as we wrap up this explainer, I want you to think about how your own digital footprint connects you to the rest of the world. Every purchase, every login, every account you create forms a relationship. What invisible patterns are waiting to be found in your data?